Okay, so I'm going to do the pour through test here. Hopefully this works. My own personal meter is a bit broken right now, but it works. It's just the power button's a bit messed up. So I've got a jug of some fertilizer water here. It is at an EC of 2.3 and a pH of 6.4. I watered in 3 samples of soil with 150 milliliters of water. So there's some fertilizer in this peat moss mix. These are all the same mixes. I've taken 100 milliliters out of this sample to do the 2-to-1 dilution, and then I will do the pour through on this one, and on this one here I will do the SME on the plate. Before I get started, I also wanted to mention that you can actually buy deionized water at Canadian Tire. It's used to mix with coolant for your car, so it's relatively inexpensive. So if you want deionized water, it's there. For the purposes of this lab, I'm using city water in my hockey water bottle. I checked, and the pH is 6.4 in both, and the EC is 0.2 in the city water and 0 in the deionized water, which is what we would expect. So let's see. Okay, we start with an EC of 2.3 and a pH of 6.3. That's been watered into these. We're going to measure them, and I just want to compare the results. Partly just demonstrate how this is done, and then we can also see the differences in sensitivity. Okay, so typically for the 2-to-1, or if you remember, we're going to add about the same volume. So up to 200 milliliters. Okay, and then we measure our pH. Turn this on. We'll rinse the probe, and in a little bit of wiggle so there's no bubbles. And what is the pH? 5.6. Let's write that down. So 2-to-1 pH is 5.6. EC we'll do after, because remember we're supposed to dilute it. By the way, you're supposed to wait like 15 minutes, 10 minutes. I'm not going to worry about it too much. But, you know, actually it's gone up to 5.8. So let's wait a little bit. Let's say it's stabilized at 5.8. I don't think you want to sit here and watch, and I don't have the skills to edit this as well. So now it's at 5.7. So you know what? Let's just call it an average. 5.7 it is, pH. Okay, so typically at this point you would rinse off your probe and store it again, and then bring over the EC probe, and we're going to add another 100 milliliters of water. So up to 300. And then we're supposed to let it sit for a little bit. EC seems to be at 0.5. 0.5. Now remember, I'm using city water, which is an EC of 0.2, so let's make a note of that. So we're going to subtract 0.2 from our results, because we're adding that with my rinse water. So very low EC in this 2-to-1, which is what we'd expect with that method. Okay, let's rinse this and do the saturated media extraction method. Okay, so we'll get rid of this plate, put it over here. Saturated media. Okay, so what we typically do here is I'm going to take this and we'll measure the soil into the beaker. Okay, about that amount. Okay, we're going to wet it till it's a slurry. Okay, so it's not completely full of water like the 2-to-1 dilution. It's kind of just a soupy mess. Okay, turn my meter on. Normally you'd wait a little bit. Rinse my meter. Okay, tip it and wiggle a little bit, make sure there's no bubbles, and we're going to measure. And pH, letting it stabilize. It is ideal. identical. It's oscillating between 5.7 and 5.8. So SME, 5, exactly 5.7 again. And the EC, remember we don't add any more water. Let me rinse my probe. All right, rinse the salt from my... All right, wiggle, get the bubbles out. And EC is somewhat higher. It's sitting at 0.7, which is what we would expect. It's higher than the 2 to 1. 0.7. And remember, you have to subtract 0.2 because I'm using city water, which is 0.2. So that's pretty much rock solid. All right. Lastly, we'll do the pour through. Let me rinse this. Same thing applies to the city water subtraction. All right, so here all we do is take our pot, put it on top of a beaker, and then what's important is when you're adding your water, you want to irrigate the entire surface so the column of water is moving through the whole pot. Okay, so I'm going to keep adding until it starts to dribble out the bottom. And I want around 50 milliliters to make sure I've got enough to cover the pH and EC probes. It takes a fair amount before it starts coming out the bottom. This is sort of reminiscent of your aeration lab, right? Whoop, starting to drip. All right, we can see that. Let's let it drip. We are approaching 50 milliliters, not quite. We need to go a little more. Let me tip that, see on an angle if it's enough. It's not quite enough. Let's add a little bit more water. Okay, there it goes. And yes, we have enough. Okay, so turn on my meter. I'll do the pH first. Let's give this a... Put this on the plate, and I'll get my bench all wet. And pH is... Interesting. 5.3. 5.3. So pour through. pH is 5.3 and EC give it a good rinse. Look at that. 1.4. 1.4 EC. Subtract 0.02 for the city water. So our final numbers are 0.3 EC for the 2 to 1, 0.5 EC for SME, and 1.2 for the pour through. And our pHs are identical except the pour through has quite a bit more, quite a lower pH. And I'll tell you, one of the big differences here is that with the pour through, the entire pot has been sampled, and we've moved water through the entire column. The SME and 2 to 1, we're using a small fraction, so it's a little less representative. That's why in the lesson I talk about taking soil samples from up to 8 to 10 different pots to average it out. But typically the numbers are reduced. Think about it like this, you know, if I take a piece of soil from the top of the pot and I measure the saltiness in it, I'm going to get the salt that was in that little piece of soil. But in the pour through, if I take that same area and I pour water over it and it has to travel all the way through the column of the pot, it's going to pick up the salt from all the soil all the way through the pot till it comes out the bottom. So it's collected the ions from the entire column. So there's quite a bit more. And as far as the pH is concerned, it's quite possible that because water's interacting much more with the soil, that it's a little more representative of the pH as well, especially since I'm using city water, which has some buffering capacity. In that sense, I probably should use the deionized water. But you can see how whichever method you choose, you want something that's consistent, right? So if you work with large pots, then you want to do an SME or 2-to-1. You know, reach down, take a fistful of soil, put it in a bag. Do a few pots, put them all in the same bag, then do the assessment on that bag. If you work with smaller pots, like in an ornamental farm, you're going to do the pour-through assay. And pour-through, like I said, you can do up to about 10-inch, 12-inch pots fairly well. Beyond that, it doesn't work so well anymore. The other thing to keep in mind is the pour through, you're completely saturating a pot. And if you do that regularly to plants, you may end up causing a root disease situation. So it depends on the context and what you're able to do. But yeah, so that's pretty much it. I hope this is interesting. I know you're going to learn from other instructors how to do this all again. And some of them are quite particular on letting the sample sit for an hour or half an hour. My experience has been that it doesn't change that much after a few minutes. What's most important, I keep saying it over and over again, is that you're consistent, because then you can compare your results. So once you've got something that works for you, stick with it. Calibrating your probes is important, but sometimes people get a little out of control on that and they overdo it and they mess up their meters. So what I would suggest is you have some standard solutions that you can throw your meter into to check, but not necessarily go through a calibration every single time. Just drop them in, say, okay, it's pH 7, that's good. My EC standard is 1.2, that's perfect. Okay, I'm gonna go do my tests. My experience has been if you constantly go through calibration procedures, that eventually the meter starts to fail. I don't know why. We've had that with our Hannas. We've had that with our Blue Labs. This is an auto grow. It fell in the water. That's why I had to take it apart and get it to work. But it still works. It's just my power button doesn't work. What else? There's another thing I wanted to say, which I thought you might find interesting. The water that I was using, the fertilizer that I put in here, was an EC of 2.5. And we didn't get that coming out the bottom, right? So there was already water in the pot, which was diluting it. But what I would like to point out, and this has been my experience as a commercial ornamental grower, is that when you irrigate a crop, the water moves into the top and displaces water at the bottom, depending on how wet or dry the soil is. But you can actually replace a column of water with a different column of water. They don't always mix. They just sort of displace. That's something that we've learned over the years that, for example, let's say your EC, let's say you do a pour through and your EC comes out really high. Like, oh my goodness, I'm going to damage my roots. What should I do? You could say, well, then in the cannabis world, flush your crop with just clear water. The problem with that is that clear water will leave nothing behind, or very little in the way of nutrients. And your crop may suffer, it may slow down. Some of these crops are very hungry and grow quickly. And what I would say is that you can actually irrigate with the target EC you want by just chasing it through. So if you have an EC in the root zone of, say, 3, and you want it to be 1.5, you can irrigate with a 1.5 EC solution, and it'll most likely displace most of it and replace it with a 1.5 EC root zone. It's not quite exactly like that, but it's pretty close. And in the world where you're worried about giving no nutrients, that's helpful. A lot of ornamental crops don't like having no nutrients, because depending on, say, the time of year, say you're growing in the winter, you don't irrigate every day, which means if you have to do a clear shot of water to lower the root zone EC, that crop may not get feed again for a week to 2 weeks, depending on your conditions. And that's a long time for the roots to have not sufficient nutrients. So just be aware of that you don't have to leach with clear water. You can leach with water that has a target EC. You could undershoot, so use an EC of 0.8 to wash out your EC of 3, and you might be left with 1.5. That's something that you would experiment with as a grower and get to know your system and what works. Just be aware, you don't have to use just clear water. That's what I want to try to say. I think that's about it. This is not a lab for you to hand in. I don't know how many of you have ECPH meters. Obviously, Amazon and whatever online purchasing system you want to go to, these things have become a lot more inexpensive. It's easy to say, well, those cheap ones aren't very reliable, but to be honest, our experience has been that it almost doesn't really matter what you buy. Reliability is questionable with all these things. Greenhouse is a wet environment, stuff gets dropped. Um, you know, Check your online reviews, try to find something that's reasonably stable. That would be helpful. I find the Blue Lab ones are not bad. Hana ones, we've had a lot of problems with them, the software glitching out, especially like the calibration thing. These AutoGrow NutriTest ones are very good, but these are pro grade. They're like $600 US. So, I wish I hadn't dropped that. So there's lots of little meters out there, and hey, if you're really ambitious, you can get a voltmeter and you can calibrate it against someone else's meter and just stick it in. Here, let me go get you a voltmeter. This is just an inexpensive, I'm going to set it to DC. And I'm using ohms or resistance. Okay. And then I can put it in here. And I get a value. So it's showing a certain number of ohms of resistance. Ohms is a way of measuring the resistance to flow of electricity. It's kind of the opposite, right? You could use milliamps. If I go here to, I'm off scale. So amps would work just fine. The resolution's maybe not quite as good. Nah, it's not very good. I think ohms is probably the better way to go. So there, I'm reading around 195 ohms. It's bumping around. It's close to the scale on it. There we go. The numbers may not mean anything, but you can calibrate this to something if you want. I would just go buy the meter; it's easier. But if you really want to be a cheapskate or something like that, this is a way to do it. All right, I think that's about it. You'll be seeing a lot more of this in horticulture, let me tell you. It's an important thing to do, to track, to monitor as a grower, keeping your notes, your records. It's a good way to avoid root diseases, to keep your crops finishing on schedule and at top quality. So monitoring what's happening in the root zone is really important, and this is how you're going to do it. All right, take care.